Welcome everyone to the Cardano Effect Podcast, Episode 9. The purpose of this podcast is to take high-level developer information and projects that are occurring within the Cardano space, within the Cardano ecosystem, and break them down into bite-sized, consumable pieces of information for everyday use. I'm your host, Philippe, and let's get this podcast started. So this podcast is going to be a little bit different today. We're actually going to do a recall of the Plutus event, the PlutusFest, last week. So PlutusFest happened on Tuesday, December 11th, I believe, and it was at the University of Edinburgh in Scotland, and we had a great time. So this was the first time that Sebastian, Rick, and I met face-to-face, and everyone was just wonderful. We have a lot of thoughts to share from the event, but I was very impressed. The room was full of academics. Professors were there. Charles Hoskinson was there. Everyone, multiple people gave speeches. We're going to be talking about those speeches later on in the podcast. So feel free to comment down below and engage in a conversation. We're going to be bringing up some interesting points. And this is going to be a relaxed episode. We have no special guest on this episode. It's just going to be the three hosts that usually run this podcast, Sebastian, Rick, and myself. Thanks for all the feedback on Reddit, and thanks for subscribing to our YouTube channel. Thanks for contacting us on Twitter and via our email. We really appreciate all the support. We are growing, and we're reading everything. I know it seems like we're not getting to everything in the email, but eventually we will get to these things. It's a lot of things that we have in queue. So we have a lot of special guests coming up in future episodes, and we have a lot of special events planned. So without further ado, once again, I would need to remind everyone that none of what we say on this podcast is financial advice or should be construed as financial advice. You are your best financial advisor, and if you don't think so, find someone who is. So without further ado, I'm going to pass this mic over to Rick. Rick, how are you doing today?
Hey, I'm doing great, Philippe. Thank you for asking. And I want to remind our guests that this podcast is also available on Google Play, iTunes, Spotify, SoundCloud, and Libsyn. So it's available on many different outlet medias. You might have different apps that access different medias, but those are the ones that you can get in audio only. To go into the PlutusFest, well, first thing I was going to touch on was latest news in Cardano. So I pulled up a few tidbits. And today is December 17th, so by the time this is released, it'll probably be by the end of the week, around December 20th. And so the latest news in Cardano, number one, is the Cardano Foundation has decided to strengthen the Foundation Council with 3 proven experts from the Cardano ecosystem. All right, you have newly elected members from the Cardano Foundation Council, and those are Nathan Kaiser, the General Counsel of IOHK, Manmeet Singh, CIO of Emergo, Domino Berkey, a managing partner of Dulac Capital Limited, and Nathan Kaiser has been elected chairman of the Cardano Foundation Council. Okay, so that's our new chairman, is Nathan Kaiser. He succeeds Pascal Schmid, who acted as the interim chairman, and Pascal will continue to be a member of the Foundation Council. And a few of the comments from both Pascal and Nathan. Pascal said that, "I'm delighted that we have been able to add 3 proven experts to the Board of Trustees in such a short amount of time. This means the Cardano Foundation is now back on solid ground and can fully dedicate itself to the upcoming tasks within the framework of the Foundation's purpose." And from the new chairman, Nathan Kaiser, he states that, "I would like to thank Pascal Schmid for the tremendous work he has done in an extremely intensive phase of the Cardano Foundation. Pascal's knowledge and the skills of the 3 additional Foundation Council members complement each other very well." So good job to the Cardano Foundation, and we're glad to see you guys back up and running, and we all look forward to what will be coming out of the Cardano Foundation for the year 2019. We got very high hopes, and we think it's going to go well. Next tidbit in the news is that Cardano 1.4/2.0, but Cardano 1.4 has been released, release date of December 18th. This will be a significant change to the code base. It's basically an entire rewrite of the Daedalus wallet compared to the original 1.0 wallet. There will be a video coming out talking about the features. It should already be out on the street going over the features, so look for that video that goes over the 1.4 releases. If you have not yet updated your Daedalus wallet by the time you see this video, it's a good idea to go in and make sure you are running Cardano 1.4. And watch for videos coming out from myself, Philippe, and Sebastian related to Cardano 1.4. We both, Philippe and I, plan on doing installation procedures and any new features that you need to be aware of and how those features affect the performance of the wallet. What I'm expecting to see in 1.4, I've looked over on GitHub and it has the features and fixes listed there. As of today, it looks like there's going to be some gains of performance and less disk space usage, but we'll see what comes out there. Last bit of news is from Charles' Twitter feed. That's a great source of news, of getting the latest information. He flew home after finishing his final trip of 2018. Now, Charles went to 30 countries and 58 events this year. That's a lot of travel. He flew around the entire world 6 times the equivalent distance. And he says, thanks for all the memories, kind words, support, and friendship. 2019 is going to be a truly special year for IOHK and Cardano. And so I'd really like to thank Charles for putting in all that effort. That's the kind of thing CEOs need to do. They got to get out there and meet all the customers and potential marketing areas. And it takes a lot of travel, it takes a lot of work. So good on you. Thank you for that kind of work. All right, so that was our quick news in Cardano. And then we're going to move on to PlutusFest. So summary of PlutusFest of who were the speakers and what were they talking about. There was a lot going on. First of all, at PlutusFest, we had Professor Philip Weidler, and Professor Weidler spoke about peer-reviewed research. We had Professor Aglos Kiayas. He spoke about the Blockchain Technology Lab. And you'll have to excuse me if I do get somebody's name wrong. I've watched a lot of videos to try to learn how to pronounce them correctly, but sometimes I just don't get it. Third on deck at PlutusFest was Mr. Charles Hoskinson. He gave the keynote address. Then we had Simon Thompson, who spoke about Marlowe. And the big things in PlutusFest, the main key things was Plutus and Marlowe. Next after Simon Thompson was Manuel Chakravarty. And he is a language architect behind Plutus. Plutus was kind of like his idea to put that out there. We had Michael Peyton Jones and John Mueller, who gave demonstrations and spoke also on PlutusFest. We had Duncan Coots, who gave a really cool presentation. It was basically show me the evidence. That was the driving point behind the presentation he gave. And he was very adamant about that. Evidence, evidence, evidence. Okay. And lastly, we had Rebecca Valentine, and she spoke on the significance of Plutus and Marlowe and also delivered the closing remarks. So that was the lineup at PlutusFest. And I would also like to thank Maki Mukai, who did a really nice write-up, a very nice summary on the Cardano forum. If you go on there and you search Recap PlutusFest on the Cardano forum, Recap PlutusFest 2018 in Edinburgh, Scotland, she summarized the entire thing in a nice, concise manner. Really good read. So if you want the short read, go there. Great stuff. And she put a lot of links that you can use to get to things like the Plutus Playground and get over to Marlowe. And one thing I found really cool prior to PlutusFest starting, one thing I really enjoyed is I got to meet my fellow Guardians, or the Guardians that I worked with for a while there, Marcus, Tim, Robin, and Bert. I got to actually meet them in person. Another really cool thing, I got to meet Philippe and Sebastian in person. Like you said earlier, we actually got a good picture together. Maybe we'll stick that in a video somewhere. I also got to meet my fellow members from the Cardano forum and on Telegram. Robert, who goes by Bobbert on the forum, Vasil, Stefan, a lot of other folks. I also got to meet Stuart McKenzie of Fractalide. That was great. I met Maki, Tom, Yeji, and Laura from IOHK, like basically in the lobby of the hotel because we're all staying in the hotel together. That was really cool. And over at the Bay Center, I came across Tamara, Richard Wild, Jane, lots of other folks at the I forget the name of that center. It starts with a T, the big auditorium. That's where I got to meet Charles, Duncan, Lars, Philip Kant over there where the auditorium was located and where a lot of the films are going to come from. And there were just so many people, and I got to meet so many people. I loved it. It was fantastic, and I really look forward to more of these events coming up in 2019, and I'll do my best to get out to them and meet even more folks. So that was a quick summary of what PlutusFest was. Lots of folks there, as you can see by some of the pictures that you'll find online. And so, Philippe, I don't know if you wanted to roll in here. Did we want to start off with Professor Weidler and his peer-reviewed research discussion he was talking about, or did you have some other things you wanted to throw in there at the beginning?
Yes, we can start there. I just wanted maybe to throw in like a little bit of my experience as well. I enjoyed meeting everyone, and this is my first time meeting people within the Cardano community face to face. So I was anxious, but I was very excited to meet everyone, and everyone's very down to earth. Everyone was very nice. Everyone got along. I mean, you could go up and speak to the academics. You could go up and, Duncan Coutts was available to speak to, and everyone made themselves available to speak to. I got to meet Charles, and Charles is a great guy. Rick and Sebastian, great people. Everyone in the community just seems to be very positive and enthusiastic and just excited about the future. And everyone came from different backgrounds. You have some people that have their own business, you have developers, you have just people that maybe want to learn more about certain crypto projects, but everyone came from different walks of life, different backgrounds, and it's almost like we all converged for this single experience. And PlutusFest was incredible. It was a performance. There was a lot of things going on, and I learned a lot. And I'm not sure, Sebastian, how you felt. How was your experience with PlutusFest? I know you've been working with Emergo, so you are more familiar with your coworkers, but I'm sure that you met some new people as well. How was your experience, Sebastian?
Yeah, I think one of the greatest things for me was just, because IHK is a global company, people work from all over the world. It was really great to just meet people in person, right? People who you've had Slack calls with every week for months. You finally meet them in person and have a beer with them or whatever. And that's a really great experience to just, have the face-to-face connection. I think that's probably the biggest takeaway for me from the event as far as personal connections are concerned. I think being able to work well with somebody is really important for the success of a business, and being able to create these face-to-face connections with all our partners at IOHK was really important for us at Emergo. And so I think that's one of our biggest takeaways. Obviously, the technology was really amazing. I had seen parts of the Plutus code here and there when I was checking out the code base, but finally seeing it in person, running in a live demo, that was really something great, because people have been wondering about Plutus for a while. Obviously, the code is evolving, but it's hard for people to translate the code into a product, right? And so people see the roadmap, it's like, going up in percentage, and people are not sure what that means. It's gone up 2%. What does 2% mean? And so it's finally great to see a presentation that, really walks you through it, all the work they've done, and a link for people to play with. And I thought that was really amazing, because then people can see, okay, we're at, I forget the exact percentage now, maybe like 20% done. What does 20% done mean? 20% done means this website, here's what you can do, you can try it out, and, run it locally or on the browser. And I think this really helps people understand where we're at with a project, the kind of stuff that can be built on Cardano, and hopefully it'll help more people get involved in the discussion as we go forward. Because when it's just a academic project or a engineering project, it's hard to get people involved, right? Because it's very intimidating. You go there and it's like a academic specification and just a huge amount of code, and people are not really sure where to join. But when people can go on their browser and kind of play around with it, get a feel for it, then they can come up with ideas and suggestions and really get involved. And so I think this is something I'm really looking forward to. And in fact, at the event, I think a lot of people actually were inspired to try out Plutus and try and contribute to Plutus. Actually, especially in the academic track where I was at, there are some people with some really great questions who had never really been introduced to either smart contracts or Plutus before, and they were really getting involved with the thought process and the trade-offs and all this kind of stuff. And I really hope these people will continue to be part of the discussion going forward. So I think it was just a really great event. And that's kind of my thoughts on the event as a whole.
Yeah, that's good. That's a good overview. Thank you for that, Sebastian. And I'd like to go back to the beginning of the discussion that they had there with Professor Weidler. Now, I know when he first started speaking, I was just so excited that I can't remember exactly what he said. I had to go back and say, hey, do you have the PowerPoint presentation so I can go back and look through it? Because I was like, oh my gosh, look at all the folks here, and it was really nice to meet them all. But he spoke on peer-reviewed research, and one thing I like to point out, with Cardano, as opposed to other cryptocurrencies that I've read up on and I'm involved with, is that it's using peer-reviewed research to create it. Now, most people know that because a lot of the early YouTube videos and advertisements say, yeah, we're using peer review. And, what does that really mean in helping the cryptocurrency technology evolve? Well, that means that it's got a solid foundation, because these papers, they write them and then pass them around, have other people look at them and say, hey, is this right? Well, you can get away with writing a research paper and saying, okay, this is the research that we did as a group, and then we're going to go ahead and build based off of this research paper. But you didn't have other experts check it for you. And so he said one of the magical tools that academics have, or one of these amazing superpowers, that's what it was. One of the amazing superpowers that academics have is this thing called peer review, where you can take your research papers and you hand them out to other people, and they can check it and tell you if it's right or if they think it's wrong. Because sometimes you do a research paper and you get it wrong, so you got to go in there and get someone else to look at it and they can review it. One of the first videos to come out from the PlutusFest is Professor Weidler's video. It's about 8 minutes. You can find it on YouTube if you just search for Professor Weidler and PlutusFest. You'll get that one on there. There will be more videos coming out, but how long was the total event? I mean, the elapsed time might have been about 6 hours of actual presentation time, roughly. I don't remember exactly, but those will be edited and made nice and good quality, and get those out on the street eventually. But did you guys get a chance to see Philip Weidler's video, or did you pay attention during the actual presentation more so than I did, where I was distracted by, wow, look at all these people that are here?
I paid attention to his speech. I thought it was very good. I think it was a good introduction to the conference. And just to reiterate what Plutus is, this event was called PlutusFest, but they were showcasing Plutus and Marlowe. Plutus is like the backbone behind Cardano when we're talking about smart contracts, and Marlowe is built on top of Plutus to allow like non-programmers to build their smart contracts within Cardano. So it's like the ease of use. Marlowe is the ease of use. Plutus is the backbone. First thing that happened when we walked in is we had a napkin, and this napkin, I have it right in front of me. It's supposed to have the entire code base of Plutus, obviously in a summary format, but it's supposed to be able to fit on a napkin. And Charles said that in his AMA, and it's printed on gold here. So they fit Plutus on a napkin. And this was the entire, I think you can sum up the conference by this. It looks so clean, and this is what's going to protect the smart contracts in the future for Cardano. So this is what the academics, all those papers being written to come up with this elegant piece of code right here. And I think that was a great summation of PlutusFest in general. But speaking about what Professor Weidler said, I wanted to ask Sebastian, wanted to segue to Sebastian, because I'm not familiar with Solidity. Solidity is the code that Ethereum developers use to build their smart contracts. But Professor Weidler was talking about how in Ethereum, sometimes you have to know Solidity, and in addition, you have to know Java, because you're building like on-chain and off-chain solutions. So he was putting a specific example of how one smart contract had like 81 lines written in Solidity and I believe 149 lines written in Java. So before, I was under the assumption that developers only needed to know Solidity or be masters in Solidity, but it seems like the barrier to entry to become an Ethereum developer is even higher than we initially thought. Is that correct in that assumption, or can you add anything to that?
Yeah, I can add to that. So it's not Java, it's JavaScript. So JavaScript is the language you use for basically making websites. You don't have to use JavaScript to make websites, but it's the most popular programming language to create websites. And so you can imagine if you make a smart contract, for example, you're the author of CryptoKitties, right? You make your great CryptoKitties application, but then you need to create a way for people to interact with it, right? And that's what the CryptoKitties website is. You go to the CryptoKitties website, you start looking at the marketplace, find a cat that looks good, purchase it, and all that. So somebody needs to create the UI experience that interacts with the smart contract backend, okay? So if you look at the code for the CryptoKitties website, you'll see a lot of JavaScript code that's essentially calling the smart contract back and forth, okay? And the problem that you have with this experience as a programmer, okay, is imagine you want to release a new version of your smart contract. You make some change, make some upgrade, and you want to swap it to a new version, make a version increase. Now you also have to make sure all your JavaScript code matches the new Solidity smart contract that is backing the application, right? Because if you imagine you change the backend, you change the Solidity code, and if you forgot to change the JavaScript, suddenly things will stop matching, right? You'll get a bunch of strange errors, the types didn't match, the data structure didn't match, and this is not a good user experience, right, as a developer. Because it just means that whenever you do an upgrade of either your JavaScript code or your Solidity code, you have to be really careful about what changed and to make sure everything still matches. Okay, so one of the problems they want to solve with Plutus is what if you just had one programming language that generates both of them? Okay, you write the program once, and then it generates the code to put on the blockchain, and it generates the code to put in your website. Okay, and now you have a much simpler experience. Because as a programmer, all you got to do when you want to release a new version is to change the one programming language, which is Plutus TX now. Okay, you make a change, and then you press go, it compiles, and then you get two pieces of information. You put one of them on the blockchain, you put the other one on your website, and now you're good to go. You know you've done a good job. And this is a much simpler and a much safer way to do software upgrade. And so I thought this is a really good idea. It is actually a problem that not many people have really thought of trying to solve, despite the fact that it's a common problem a lot of developers run into. And as they said in the conference, this is not a new problem in computer science, right? This happens all the time. For example, you have some sort of C# application, you want to connect to a database. You make a change to your database, but then now your C# code doesn't match anymore. You got to change the C# code and make sure everything matches. Stuff like this is very common, and every time when you have this problem, people always create this kind of intermediate step that creates both of them, right? So they have some way of automatically generating code to make sure everything always matches. And I think it's only natural that we have this next step in smart contract development, where we also notice that there's this mismatch going on, and now we have a unified way of writing smart contracts that generates both paths. And this will be a natural step for developers to kind of make the smart contract authoring experience much easier, right? So one thing people may not notice when they're not developers is that writing a smart contract is not the best developer experience. And the reason why is because if you think about programming languages that are well known, Java, C++, C#, all these well-known programming languages, they've been around for a very long time, sometimes decades, right? And so they have a very rich, well understood user experience, right? You have this IDE, we know this IDE works, we have all these known tools that work, and this experience that just works, that everybody's known for a very long time. Solidity in smart contract development is a very new experience, right? It's not something people have thought that much until fairly recently. And so there's still a lot of tooling that need to be done, and a lot of questions that need to be answered. And I think Plutus is really helping to push us forward in that part of the field, right? Because I think a lot of people who write the tooling, they're interested in making small incremental changes. They make the compiler 1% faster, or the runtime 1% faster. But sometimes you need to come in and say, okay, we can get the 1%, or we can do a pivot into this new strategy, and that'll really push us forward. I think that's kind of one of the things Plutus is aiming for.
Sebastian, one of my biggest takeaways during the PlutusFest briefs related to that was, as a non-developer myself, non-programmer, I noticed that comparison that Philippe was talking about. They showed the Solidity code and the JavaScript code, and there was a certain piece, and one of them runs on-chain and the other part runs off-chain. But what I noticed, the difference with the Plutus code, the two things that I learned during that particular part of the brief was Plutus is a subset of Haskell. So Haskell is the entire language, and Plutus is a subset of that. Did I get that part correct?
Yes.
Yeah, that's right.
Okay, so I got that part correct. And what was even neater is, instead of having these two chunks of code base, it was only one set of code, and then inside the actual Plutus software that was written, this was the demonstration they were giving, there was the segment of code that runs off-chain, and there's the little piece of code that runs on-chain, just by using special characters to mark that part that runs on-chain. And to me, it looked a lot more efficient, and it was all in one piece. And did you guys notice that as well? Did I catch that correctly?
Yeah, I mean, so that's what I was talking about, right? So it's a much easier experience as a software developer if you know all your code is just one file, okay? And you edit this one file, and you make sure everything is working, and you press compile, and it gives you the two files, the on-chain and the off-chain. And that way you know there's no weird thing where the versions don't match. Everything's generated from the same source code. And actually, this is not just important in Plutus. I was mentioning before that the database with C#, but another platform that's trying to solve this problem is the K framework, right? So what's the idea behind the K framework? When you create a new programming language, you don't want to create the compiler from scratch and then create the interpreter from scratch and then create the debugger from scratch. You should just have one language. You write your language in that. You write your new programming language in that one framework, and then suddenly it generates all the tools for you. And this is a very powerful idea, right? Because it just saves so much engineering effort, and the cost savings are so high of not having this mental overhead of having to rebuild all these tools, that it can enable a much more efficient pipeline. And this philosophy kind of goes even further for Cardano in general, right? Because if you imagine Cardano in the future, what will that look like? Well, one thing is that it will be in a decentralized mode, right? In the future, it'll not just be IOHK, it'll be many companies. And so you're a company, and you want to propose a change to Cardano. You say, okay, I think we need this new feature to enable this scenario my company needs, right? So that'll be the Cardano improvement proposals. How would you make a Cardano improvement proposal in such a way that everybody can agree on the meaning and everybody can generate their new clients based on the change that you're proposing? Well, the easiest way to do it would be make it a change in the spec. Okay, when you make a Cardano improvement proposal, you say, okay, here's our spec, and I want to change this line to do this new thing, okay? And then every client, the Haskell client, the Rust client, maybe a Scala client, or whatever there is in the future, all they do is they take the spec, crank the wheel, generates the code, and then they put that in their new client. And that's it. It just did all the work for them. They generate the executable from the spec. And that would be a great pipeline, right? Because then we know all the clients are all conformant to the spec. There's no some weird version mismatch, and then when we go to launch the new version of Cardano, Rust client doesn't agree with Haskell client, and then what do we do? And we wouldn't have this problem anymore because everybody knows their code is just generated from the spec. And this idea of generating code is super powerful, and I think maybe people don't realize how much time this can save in development, right? So for example, Ethereum had a problem, I think maybe 1 month ago, 2 months ago, where they're trying to release a new version on their testnet, and they had a problem because they had one client that did not agree with the other client, and it caused a weird hard fork in their test client. And the end result is they had to postpone the version improvement by a few months. I think it was like 3 or 4 months they had to delay it by, because okay, we need time to improve our test suite and do some more testing to figure out where the bug is, and then fix it and make sure it matches. And there's a huge amount of effort that goes into this, right? And if Cardano in the future can say, okay, we just change the spec, everybody generates their code from the spec, everything matches, then it'll be much faster, right? We won't have to have this weird issue with all the hard forks and trying to figure out what went wrong. And so we can have this at the protocol level, but we can also enable engineers to have this at the smart contract development level, right? So when somebody writes a smart contract and they want to make a change to their smart contract, they don't have to worry about version changes and everything. It just works, and everything is generated from this one file.
There was also something I noticed in the code, and maybe I read it wrong, but like at the very beginning of the Plutus software, there's a version number. So when the compiler reads it or whatever reads it, it goes, oh, that version. So it knows the correct version that you're using for that smart contract. Is that correct? Is that what I saw in there?
Yeah, so the version inside these Plutus smart contracts is not the version of your smart contract that you're writing. It's the version of the programming language you're binding to. So, for example, if you think Ethereum, because this is a well-known problem, in Ethereum they have version upgrades ever so often. New versions of Solidity come out fairly often, right? And of course, we will have the same thing in Cardano, right? Every once in a while, it's okay. We have a new version of, for example, Plutus. We've made it 5% faster or whatever improvement we come out with, and people will have to migrate to the new version. But obviously, not all smart contract writers can upgrade their smart contract. Maybe I wrote my smart contract for version 1.0, and then version 2.0 is incompatible with my smart contract, and I don't have the engineering work to fix it, and I already uploaded my code to the blockchain, so I can't change it anyways, right? So we have, every blockchain that has smart contracts has this problem, right? And so the smart contract inside it specifies the version of the programming language that's used. That way, 10,000 blocks from now, 100,000 blocks from now, 1,000,000 blocks from now, your computer still knows which version of the language to use to compile the smart contract. Okay, and that ensures you have immutability throughout the history of the chain.
That makes perfect sense. And I think that you highlighted a very important point. And this point of basically it's like a one size fits all. And Cardano is creating Plutus to try and decrease the barrier of entry for developers to develop smart contracts. And I think that's key. And when Sebastian, you said that, imagine the cost savings. I mean, when we translate that to business, say an institution or a company wants to build a smart contract, not only are they going to have developers, like for example, if it took place in Ethereum, they'd have to have developers on site to continuously maybe update that smart contract because it may not be compatible with the latest versions of that blockchain, or they may need to have person A develop in this language and then also write it in JavaScript. There's a whole bunch of different issues with the second generation blockchain Ethereum, and Cardano is trying to solve those issues and make this coding process, make this development process a lot more simple. And I know you're hearing about Ethereum a lot, and it seems like we're bagging on Ethereum, but that's the standard right now for smart contracts. And I was at PlutusFest, and when you observe people at PlutusFest, all the academics, I made a video about this, and I basically said that all those academics that were speaking, they're blockchain agnostic. What does that mean? They just want to find the best solution out there. Say you're a runner, you like to run, you just want to find the best running shoe out there. If you're going to choose like an ASIC shoe or a Sasoni shoe, or you're going to go buy a Reebok shoe and hurt your feet. That's what Ethereum is right now. And, I know you're going to put some hate in the comments about that, but it is what it is. The people, the academics, they're not worried about the price. They're not worried about when ADA's going to moon or Ethereum's going to moon. You don't see them in the Telegram group talking about that. They just want to build on the best possible blockchain. And Cardano is providing those solutions. So when we're saying things or critiques about Ethereum, it's because it's true. It is true. So, next time, come to PlutusFest next year, listen to the academics talk, and they'll be able to explain it in a better way for you to understand exactly the solutions that Cardano is seeking in order to better the experience for developers. What do you think, Rick? Do you think I summed it up pretty well?
Yeah, you did. You summed it up pretty well. What I'd like to do is segue to doing a demonstration like we saw at PlutusFest, and I can't do it nearly as good as they did at PlutusFest. If you guys are okay with it, I want to attempt a screen share and show what we saw. I practiced it once. I don't know what I'm doing, but I can monkey see, monkey do my way through it. And if it doesn't work, we'll just clip it out. You guys, you want me to give it a shot?
Go for it, Rick.
I'm going to go for it. Okay. All right. So let me go screen share. And what I'm going to do is I want to show you how to get to the Plutus playground and how to get to the Marlowe creation tool that Sebastian demonstrated in one of his videos. Okay, so let me see. I'm going to do screen share. I'm going to do an application window and share that. Okay, and what you're going to see, if it's working correctly, is you see the recap, PlutusFest 2018 that Maki put together. Do you guys see that okay?
Yes. Yes, I do.
All right, and I'm scrolling
Thanks,
up
Maki.
and down, and you can see that okay. All right, so she did a magnificent summary here. So let me scroll to the bottom. I don't want to make you dizzy scrolling up and down. And I'm going to have to speak verbosely to what we're seeing because if you're listening to the audio podcast, you're not going to know what you're looking at. So I went to the forum.cardano.org, recap PlutusFest 2018, made by Maki. And I go to the very bottom, and she put useful links at the bottom. And if you go down to the fourth link, it says Plutus Playground. So I'm going to click on that. Now I already have it open, but I'm going to open up a new instance of it. Wait, oh, all right, let me go back and just select the Plutus Playground. And here is the Plutus Playground. So it opens up a new link to the Plutus Playground. And here's the code. So there's 3 sections to this. And it will explain it. If you go to the top right and you select the tutorial, it'll explain this. So the top section here, with actual Plutus code running inside the web browser. I don't know what it says. I can read the comments and I understand what those say, but I don't know what the actual code is. Okay, but it's really cool. Okay, then you hit compile. So I'm going to compile this code. Actually, this isn't the one I wanted. I'm going to select on the top right. I'm going to hit game. And that brings up the code for this little game. All right. The Plutus, which is a subset of Haskell. Hit compile, and it runs the game. And I'm going to scroll down. And if you notice, I scroll down as hard as I can. I have these wallets. Now, there's more stuff that's going to show up down below. Okay, so I got wallet 1 and wallet 2 here. And I'm going to punch in some data. Now, I don't know exactly what this is doing, so if I goof this up, Sebastian, just say, nah, Rick, you did that wrong. But I'm going to put in 2 ADA. I'm going to hit pay to public key, get value 2. I'm going to send it to wallet number 2, fix errors. Oh, hit enter. There it goes. Okay, and that sends 2 ADA from wallet 1 to wallet 2. I'm going to add wallet. There's wallet number 3. I'm going to send 3. Whoops, I don't need to change that number. We hit pay to public key. I'm going to pay 3 ADA. I'm just playing around with this. I don't know if I'm doing this right or not. But this is the thing you'll play with. I'm just trying to show you where to get to this. Hit enter. Hit evaluate. Okay, and it makes the transactions. Now I'm going to scroll down further, and it makes this really cool graph down here. This is the part that amazes me. You know, I don't know what it's doing. It has some sort of blockchain shown here, and then the transactions where the money went from wallet 1 to wallet 2 and wallet 3, and there's a balance stuff going on down here where now wallet 2 has 9 and wallet 3 has 13 in it. It doesn't look exactly like the first time I ran through it. Let me try it again. I'll restart it here. Just refresh, reload the browser. You guys can still see that browser?
Yes.
Okay. And so the game. So there's other stuff, something called crowdfunding. There's a game. There's messages. There's vesting. Okay. So that was just a basic idea. I wanted to show you how that works, not exactly what it's doing because I don't know exactly what it's doing. But that was just a rough idea. So you can see how to get there. Is Sebastian, Philippe, did you have anything you wanted to say about this thing? You want me to run another through it? You're good to go with that.
I thought it was interesting because just the idea that, you know, we're on the Plutus playground And, you know, Rick and I, we're not developers, and we can go around and punch numbers. And, you know, I mean, I think if we sat down and read enough into the tutorial, I think we would grasp a basic understanding of what's going on. You know, I understood it when they were doing the demonstration over at PlutusFest. But once again, decreasing the barrier to entry. This is going to be very developer friendly, and people are going to feel very. I mean, the UI for this is incredible, and usually the UI for code is just not. It's not as friendly. I mean, it may be friendly for developers, but for people that do not have a coding based background, it looks like gibberish. But when you look at the Plutus playground, you understand that things are decreasing. And I mean, the whole one pager that they gave us about Marlowe is this whole idea to make the code as simple as possible for institutions, small, large, small, medium, and large enterprises to build their smart contract solutions. And this is the way to go. So, yeah, great job, Rick.
Yeah, thanks. I think, if I'm not mistaken, this part of the code, if I remember correctly, these special characters, this is where it runs on-chain, and the rest of the code runs off-chain. I think that was the chunk right there.
Yeah.
I could be wrong, but I think it was this marker.
That little absolute value sign, yes. I think that's what it was.
See, not bad for a non-coder. So I can imagine a software engineer could tear this up, because this is pretty small for what I've seen the software engineers create. So that was one thing. So one thing would jump back over to.
Can we ask Sebastian quickly if he's played around with on the playground, the Plutus playground?
Yeah, I mean, I've played around with it. I had, some fun trying to modify the existing smart contracts. I really like the graphs at the end where you can see the transactions and the UTXO of your mock chain. I think this system is actually super useful, in fact, independent of the Plutus playground. I mean, imagine, you're writing a smart contract on Remix, right? So, for example, if you go to the Yella testnet right now, we have a fork of Remix that works with Yella. As you're trying to kind of play around with Yella, it's easy if you have a single smart contract with a single execution. But once you get to multiple smart contracts and you want to keep track of history, of interactions, it's very hard to figure out what's happening with it within a single window. And I think the way the Plutus playground really shows you an interactive history and simulation of what is happening really helps developers understand what is going on in their smart contract and help them figure out, is there bugs, is the behavior working properly, and all this kind of stuff. And I think this has a really huge impact on usability, the speed of development, and also the interest, right? I mean, people really love those graphs. I mean, so one thing with Plutus that people may not have noticed is that it's actually been received really well. I mean, so when you're an engineer and you're working on a feature, sometimes it's very hard to figure out what people will think of it because you're so deep on the problem, right? You just think about this all day and night and whatever. And once you get to showing it to the world, you're not sure what's going to happen. And so Plutus is kind of the same thing, right? OHK and Emergo, we've been, very deep on this Cardano project for a while, and we're getting ready to show the world Plutus, and we're not really sure what's going to happen, right? But the reception of Plutus has been really good, not just at the PlutusFest event, but also on Reddit and all these other platforms, and also through the media. So we had quite a large media presence at the event, and we had a lot of articles written about Plutus coming out after the event, all very positive. And so one thing that's come out of all these people really loving this experience is that people share their experience with it, on Reddit or whatever. And a lot of people have been just sharing these diagrams of the simulation. Like, oh man, I made this simulation. Look at this really cool looking diagram. Isn't this so awesome? And it really shows that even software engineers, they're people, right? They enjoy art. They enjoy, very visual, expressive images that show what's going on in the hood. And that's why I really love what the IOHK creative team has done on this website to, help us not only market the project as something really awesome, but also, just help developers figure out what's going on and what it really means to write a smart contract.
So I'm back over to the recap PlutusFest that Mackie put out. Go all the way to the bottom. To the links, useful links. There is a link for Marlowe. Maybe it was up in the list.
Yes, Meadow for Marlowe. Third one from the bottom.
Meadow for Marlowe. That might, I think that's it. Let me open that up in a new tab.
So this tab is particularly interesting.
That was it. Meadow for Marlowe.
Yes.
Thanks, Philippe.
No worries. I was playing with this before, like months ago, and I thought it was just fascinating because one of the things that Professor Weidler said, and one of the things you hear consistently, is this idea of Plutus being like a modular system or a block-like system. Even on the little one-pager that we got, they visually represented Marlowe as kind of like Lego blocks, and the way you're going to be able to stack code on top of each other. And all the complex code is happening behind those blocks. So behind that red block, behind that green block, and whatever you want to do for your smart contract, if you want to fund your smart contract, if you want to put like 1,000 ADA in your smart contract, you just pretty much enter 1,000 ADA, create that block, give it the direction of what it's going to do, and you just plug and play. And I think that this is powerful. So Rick, I don't know if you had an example to show, but I think this is pretty interesting.
No, I don't have an example to show, but only that this this part of GitHub that has Marlowe set up in here it's functional in some way, and apparently it's easy for people who are involved in a financial system and understand how banks work. Apparently, this is easy for an expert finance person to be able to assemble the data. And I think there's going to be more work done on Marlowe on improving the visual representation. But that's all I know about it. I just wanted to make sure people know how to get to it, or so that if one of the software engineers out there see this podcast, they know where the links are and they can get to the right place and experiment and maybe learn something from there. Okay?
Oh, definitely.
Yeah, so when I was at PlutusFest, we had a few different events with media, and during that time, I was talking to one media agency, and the person that was doing the interview was talking about Marlowe, and they're like, "Oh yeah," and I just went to the website, and it reminded me of Scratch, which, if you don't know, is a different a programming platform to teach kids how to program. And like, "Oh yeah, it just reminded me of Scratch. You just drag and drop the boxes around, and you press run and see what happens." I was like, exactly. You just put some boxes around, and then you can see what happens if you were to deploy this smart contract in the blockchain. And it really shows how easy it is for people to play around, and how important it is to have something that even the media can understand. Because obviously, the media's job is extremely difficult, especially when it comes to a project as complex as Cardano. There's so much going on, such depth to all these projects, and it's really hard for them to parse it. And if they can just go to a website and just see a UI and drag and drop stuff around and play with it, it really helps clarify the concepts for them and really enables them to introduce Cardano, the work we're doing, to the world.
Yeah, and I would like to thank Manuel Chakravarti for getting this demo out there at PlutusFest, and the two fellows that came after him, and that was Michael Payton Jones and John Mueller. Those were the fellows who demonstrated this. I really admire when people can do live demos like that, because that's where I learn a lot. I saw that and was like, oh my gosh, I don't know what that's doing, but I think I can replicate that. So thanks, guys, for putting that out there.
Sebastian just made another good point, and it could tie back to our episode 1, when mass adoption. The idea that Cardano is making this block-like system, and people, like you said, are in the media, are like, oh wow, it reminds me of this, my child does this, or it's just drag and drop. How easy is it getting? So in the future, when Plutus and when Marlowe release, when smart contracts are live within Cardano, people are going to be able to build their solutions regardless of what industry they come from. So if you're a bank looking to make your smart contract, you'll be able to do it. If you're a small business, a startup, whatever your use case is, you're going to be able to communicate with Plutus through Meadow, through that Meadow block-like system, and that Meadow-Marlowe system and create your solutions. And I think that this decrease the barrier to entry is exactly what Cardano is going for. And couple that with the scientific and academic rigor behind the papers that Cardano releases. So each one of those blocks that you see, you can guarantee that that code is not going to malfunction on you. So those little red blocks that we saw, if you see 200 ADA, it's going to be 200 ADA. It's not going to do some funny thing behind the scenes and, you know, your contract's going to get messed up. That's why Cardano is taking this methodical approach to build their cryptocurrency. It's to make sure that the blocks, when it's ready to be used by the masses, are all correct and they function as advertised. And that's extremely important.
Yeah, and you know, Philippe, I want to springboard off of that back to a different subject where the second major segment of the PlutusFest presentation was Professor Aggelos Kiaias, and he talked about the blockchain laboratory work and all the different people working on the IOHK research. And he had a slide that presented very well. There were 21 papers published by IOHK. This is the research that the foundation we're talking about. 21 papers that were published that were either authored or co-authored by IOHK researchers. Okay, this is the peer-reviewed research. 5 more papers published by IOHK-funded researchers, and 20 papers submitted and currently under peer review. So there's a total of 46 papers out there to lay out and define, you know, exactly how it's going to be built. There's a really good video by Professor Duncan Coutts that explains you start with the research paper, and then that research paper then becomes specifications and so on, and it becomes more and more refined until it becomes code. All right, so that's a lot of papers out there. Sometimes you hear people make fun of Cardano. I get a laugh out of it, and they say, "Oh yeah, white paper Cardano." Well, guess what? There's 46 white papers out there. I don't know how far we're into it. I should probably create some type of visual diagram that shows 46 papers laid out from end to end, and color them in as green. This paper has been put into code, right? And yellow is these papers are in progress, and then, you know, orange or red, these papers aren't touched yet, or gray because they're NA, just to kind of show the progress of how much of the paper has been put to code. You know, that would be kind of cool, wouldn't it?
That'd be really cool, but you're going to need a lot of paper. Like, I'm not sure if people realize, but these are not, you know, small papers. Like Ouroboros Classic, the first Ouroboros paper is like 50 pages. The next version of Ouroboros Pro is like another 50 pages. Gens is another 50 pages. Crypsinus is another 50 pages. And you, like, you know, multiply it by, like, you know, 46 or whatever. This is like you're gonna be printing for a while.
And Rick, I'd like to add that those 21 papers, I believe he said that those were in the last year. So Cardano has been working. And Sebastian, maybe you can touch on this. I look at the papers as, I mean, as a developer, you get very excited about these papers because they're pretty much that formal specification that you're looking for to develop your code. So they're the dictionary that's going to provide you the guide to build what you need to build. Is that not correct statement to make?
Yeah, I think a lot of what the papers try and do is establish if this is even possible to do, right? I think that's mostly the goal of the paper. It's like a requirements gathering. Okay, so you can imagine when Cardano was just starting, okay, and Charles has this grand vision, we're going to build proof of stake and it's going to be awesome. There is a chance at that time that they could have put money into research of proof of stake and it would have been a bad result. It would have been a great paper that proves why proof of stake is not possible. It was possible that this would happen. But as we know now, it turns out proof of stake is possible, and we had really rigorous research to show why it's possible and how to do it. Okay, but there's a lot of times when, you know, engineers spend a lot of time and money building products that end up being impossible to build in the end. Okay, they think maybe this is possible, and they're not too sure, and they don't want to spend money on the research, and so they're like, okay, we'll just go for it, and they have a go at it. But, you know, sometimes it's just not possible. You can actually mathematically prove it's impossible to write certain kinds of programs. Okay? And so this is the importance of doing the research, because we need to make sure we have the requirements and the fundamental understanding before we move to the code. And so Plutus was kind of the same thing, right? If you imagine how they got it to fit on a napkin, it was, a lot of work, a lot of thought went into this. So is it even possible to create a programming language that allows you to compute everything a computer program needs you to do? It's a short specification, right? And it requires a lot of thought. And it's possible the answer could have been no, right? You can imagine maybe they spent a year on this, and it's okay, we can't get a simple system, it's just not feasible, and so we're going to need to have a more complex system with all these weird cases. It could have been possible. But it turns out through a lot of thought, a lot of work, we have this very simple version. And I think this is the importance of the paper, because now the engineers can start building a system knowing it's possible, right? They have directions for how to do it. They know it's possible to do it. It's just a matter of time and engineering effort. I think that's like the real importance of the paper.
Sebastian, I'm trying to wrap my head around that napkin with that little bit of code on there. That's called Plutus Core? That's...
Yeah, it's the semantics. So you can imagine whenever you do a programming language, you want to create a new programming language, you have to basically define transitions as your program is executing. And you want to write all the different kinds of transitions your program can do. And that is basically what that napkin is showing. It's showing you all the different kinds of transformation rules that exist within the programming language.
I wonder if that's ever been done before, like since assembly language or something like that.
No, I mean, people do it. People definitely do it. But often they end up being way more complicated. If you go online, you can find these specifications, for example, of Java or of C++, and they're literally book in size. Like, it's just, you read through this and it's just pages after pages after pages, and it just keeps going, right? And it's not easy to get a really concise set of rules that describes your entire language. And I think this is a real success of the Plutus team, but also just a success of computer science in general, right? So now in the future, if anybody wants to build a similar system, even if it's not related to smart contract, they can say, okay, what are the fundamental rules we need for this kind of system? They can refer to IOHK's work and really save a lot of engineering effort on their side and a lot of research effort on their side based on the work IOHK has done. And I think this is, the real benefit of the peer review process and the academic process, the fact that everybody's sharing their research, looking at each other's research, and building on top of it. And I think this is really a victory for the academic community in general, not just Cardano.
Think about it like this. Maybe in a decade from now, 10, 20 years, you'll see this napkin printed in some computer science book or some math book. When Cardano moons, you're going to see this. It's going to be integrated. People are going to, look at this. This is concise code right here. And this is the standards that we build our products on. And I think that you're not going to see the code for a lot of other cryptocurrencies, but you probably will see the code for Cardano written by IOHK. It's peer reviewed. It only makes sense. So that's the first code that's going to get published.
Yeah, there's something also that was interested in about the design, and that was Duncan Coots emphasized the evidence. Show me the evidence kind of stuff. So as it goes through the entire process of creating Cardano, what he described basically is you have evidence that shows that you built it correctly. I don't want to quote him, but that's roughly the evidence that it works, evidence that the specifications that you made, that the code actually does what the specification says, and then there's some software program called Isabelle that can test all your different test cases, but basically you have evidence. Sebastian, do you know what would this evidence be used for? It'll prove to yourself that you wrote your code correctly, but would that be used commercially in the future, where if somebody says, hey, I need a blockchain technology to solve a particular problem, and if I go to Cardano, their blockchain, I have certain evidence that proves it'll do what I need it to do. Is that kind of what all that evidence is collected for? I'm not sure what you would do with it in the end.
Yeah, I think it's a lot of just consumer confidence, right? So imagine you're, trying to look into an ICO last year when that was the big thing. And you're looking at this ICO and you think the idea is cool and you want to participate. And they say, okay, just send 5 Ether to this address and that's all you need to do to participate in the ICO. And you, knowing that cryptocurrencies is not the most trustworthy space, are starting to have doubts. Is this really a legitimate ICO? Will I really get my tokens? I mean, with the current state of smart contracts, that is not an easy question to get an answer to. If you look at, any smart contract platform and you look into the code to try and figure out, is this really a legitimate ICO? Are there no loopholes or backdoors or anything? It's really hard to figure out, especially if you're not an engineer. And so what we really need is a way to boost consumer confidence, right? And one way you could do that is when you go to the ICO page, we not only have the smart contract, we have a proof that the smart contract has no backdoors, or proof that the smart contract has no kind of bugs of this category. And so if you go to a smart contract for an ICO you're willing to participate on the Cardano platform, and you can see not only the smart contract, but all these mathematically proven statements about the smart contract, you have a much higher confidence as a investor or a consumer that you're using a legitimate product, right? And I think this will really help enable people to join this ecosystem, because one of the biggest reasons people have not really joined cryptocurrency movements is because they're just really unsure about it all, right? They look at this thing like, I don't know, like, does it really work? Especially when it comes to governments, right? And somebody pitches to a government like, oh, please use my smart contract to do whatever. The government's like, okay, like, who are these people? Like, what is this code? What is this blockchain stuff? Does it all really work? Like, how do I know? And if you come to them and you say, like, here's my platform, my smart contract, and not only do we have this, here's my proof that it works, and here's my proof that I engineered it correctly. And I think, people have, much more confidence in the system and much more willingness to partake in it.
Yeah, if I compare that to cars, something that's like an automobile, and people look at it and say, is it engineered correctly? Look at the airbags. If you see the commercials, sometimes they'll show where the car crashes into something, the airbag deploys, it's got a five-star safety rating. There's a lot of evidence or a lot of proof that's been collected to say, yes, that car is safe in certain conditions, So that's where I guess the average person can relate and say, yeah, that's where proof or evidence that something works as designed. Its emissions are so good, its safety is so high, the gas mileage is so effective because they collected evidence or proof to present to the consumer and say, yeah, this is how this vehicle will perform because we collected evidence. So I guess in the case of software, I can't physically see that, but if someone provides a mathematical proof and someone else can peer review it and verify, yeah, that is correct, it is going to do what it says, that would boost my confidence. So I like that explanation, Sebastian.
Better than the example you were given, right? Because so imagine you're talking about cars, okay? One thing people like to do with cars is have some sort of measure of the gas usage, right? And I think this was a scandal of a few years ago where they figured out that certain cars were tricking the testing, where you had something in the car that would detect if it's in test mode and then change the fuel usage or whatever. I forget the exact scenario, but there's something like that that's happening where people are trying to game the system.
That was Volkswagen.
Volkswagen, yes.
Yeah. Yeah. And so when you have a central authority which is in charge of testing standards and then handing out proof of standards, people will cheat it. I mean, this is just like a natural thing that happens. You can make as strict of a test as you want, but there is still an economic incentive for these companies to try and cheat the system. Okay, when we're talking about proofs in Yellow or proofs in Plutus, there is no central authority that checks these and gives it a stamp of approval or a check mark or whatever. we're talking about a system that mathematically checks and runs over your program and generates a proof that any other computer can verify. So I would upload with my Plutus smart contract or with my Yella smart contract an actual proof certificate. It's actually like a file you can check, and you can give that to a program on your computer, and it'll take the smart contract, take the proof, run the calculation, and it's like, yep, good to go. We know that the smart contract is safe under these assumptions. And then there's no more gaming the system, right? You can't trick your cryptography or your computer. You can actually check, does this smart contract match this quality standard, yes or no? And it's a yes or no answer. And I think this is going to be really awesome. It's going to really help people have confidence in these systems we're building.
So we can compare it to like Cardano's like the SSL certificate for smart contracts. We're going to have that little green lockbox in the upper right-hand corner. I know that's a metaphor, but it's going to give the consumer confidence that they're not on some kind of phishing contract or some kind of contract that has a backdoor. And I think that analogy for the gas mileage on cars and how if there's a central authority and the proofs are not proven to a certain degree, there's always going to be a backdoor and people are always going to cheat the system. 100%. 100%.
And it's funny, they did that. They actually wrote code that tells the car, if I'm in test mode, I remember reading about that. If I'm in a test mode, then cheat. And if I'm not in a test mode, then just operate normally. Wow. Pretty crazy.
Yeah. And it's weird when you think about these kind of situations because, these companies, these large institutions, they're often backed by some elaborate insurance. So they have these insurance schemes or insurance ploys to, basically they build half-assed products with the intention or with the fallback mechanism that insurance will bail them out if they ever get into some kind of sticky situation. Of course, probably Volkswagen couldn't get bailed out of this particular situation, but there are constantly manufacturers out there that build subpar products and then they are backed by insurance and then they just get an insurance write-out. The same way individual people look for insurance write-outs, institutions look for insurance write-outs. But when looking at the new financial system, when looking at Cardano, I really think it's going to revolutionize this whole system of insurance and basically gaming the system. And it's going to allow for a lot less money to flow out of the system. There's a lot of money that flows out because of excess and just poor planning, poor manufacturing, and just poor vision in general. And when I'm not sure who was talking about the escrow situation. I forgot which professor it was, but I thought that this was very interesting in terms of insurance, because what if the contract can serve as the manufacturer and the insurance provider at the exact same time? It really cuts out the middleman, and that's exactly what crypto is supposed to be about. And I think that Cardano can achieve this.
Yeah, and I think one thing to mention when talking about this is, again, we go back to the importance of research. So I'm describing to you guys this magical system. You have your smart contracts, you have a proof for it, everybody knows it works. But as a skeptic, you might be thinking, hold on, is this even possible to do? Right? Maybe it's possible, but it's also could be the case that it's not possible to do. Right? This is always a possibility, right? And so we have to do deep research on this topic and really figure out what is doable, what isn't doable, how far can we take this. And these are non-trivial problems. Like, if this was an easy problem to solve, we would have solved this problem like 10 years ago, like 100 years ago, or whatever. You'd be out there buying your piece of software, and every software would have validation and all this kind of stuff. And the reason we don't have this, because this is a really, really hard problem, okay? And IOHK has put a huge amount of money and a huge amount of effort into figuring out how far can we take these verifications. And we're doing good. We have, stuff that's gonna come out, stuff that's already come out about various properties that we can prove. If you look at just the K framework in general, either the KVM or Yella, which are already out there, already usable, you can already use tools for the KVM to prove whether or not your smart contract has certain properties. It's already done. It's just, and runtime verification, led by Gregory Rochu, is already using this as a business model, right? The business model of runtime verification, to a certain extent, is you talk to them, say, please prove this smart contract is secure for me, and they do their magic and then give you a proof at the end. And there's a good chance that this is just not doable. We could have been at the start of Cardano before the pre-sale, and be like, this is really great to have. We get the money from the ICO, we do the research, and go like, ah, shit, guys, it's not doable. You can't prove if smart contract is secure. It's a real possibility, right? It's a risk whenever you make investments into anything, right? But we've been very fortunate. We put a lot of time, money, and effort into this, and now we have a really, well-engineered system that actually has real use cases for the provability of certain properties of your smart contract. Cardano is not an old project. This is not like something we've just started, we've been at it for a long time. This is a relatively new project, and so we still have a long way to go, right? We have the KVM, which is awesome for proving these properties of your smart contract, but we still have to build similar capabilities in Yella and inside Plutus, and these things take a long time. People love to complain about Cardano, it's taking months, what's happening. But these are really, really hard problems that nobody else in the computer science space has really been able to solve. And when we get results like the KVM, where you can prove properties of your smart contract, it's really a magical experience for companies like Maker, right, to be able to verify their DAI smart contract. I forget which one they verified, but they verified an entire smart contract. It's a magical experience to be able to say, hey, we've got this smart contract. Not only does it work, it's like a magical experience as developers. Not only did their smart contract work in practice, they're now able to mathematically prove their smart contract works, right? And I'm really looking forward to, because we're just getting started, right, as Cardano. I'm really looking forward to these kinds of magical experiences that we can enable in the future. And this is going to be a great experience for developers to be able to write their smart contract, know it works, have the proof that it works, being able to deliver projects on time, on budget, in a way that they can have confidence what they wrote. These are really great things, and I'm really looking forward to what we'll be able to deliver in the future. And if the pace and the quality of the work we've done so far is any indication, then we have a lot to look forward to.
Sebastian, you just got me thinking, so it's dumb question time, and that's my job on this podcast. So my question is, if these smart contracts, they become so provable and reliable, and we get the scaling, because scaling is going to come, that's another factor. So once the scaling gets kicked in, and escrow or multi-signature, probably multi-signature, is Cardano one of the types of cryptocurrencies that maybe in the future you could build a decentralized eBay or decentralized Amazon, to where I can sell products on eBay to other individuals and there's a direct exchange of currency through this dApp, and then and we can have these transactions without having eBay and PayPal and Visa and the different entities in the middle, where if you sell a product on eBay, you're looking at many days of turnaround before you actually get paid your currency. But I mean, eBay works great in a centralized context, but is it possible to create like a decentralized eBay in the big picture?
Right. Well, I mean, so in a sense, this is like a platform versus user problem. So like the goal of IOHK right now is build a great platform with really magical experiences for developers. Okay. And when we have a great experience for developers, we hope that this will enable people to use the platform to create a great experience for users. Right? That's the dream, right? You want the whole pipeline. And so right now we're still working on the core platform and trying to build these great experiences for the core platform. And then we have to kind of see what great user experiences people can build on top of it. And so a lot of software engineering is actually just creativity. When people create the internet, I'm not sure if they imagined eBay or Uber or Amazon or these kinds of companies. You really need to, as a platform, make sure you've got a really solid platform and then see what kind of magical user experiences come from it. So obviously, people have tried these things like decentralized eBay, decentralized various platforms, but in the current state of blockchains, it's just not doable. We know it's not doable. I mean, you can theoretically do it. It's just a really poor user experience.
Yeah, I'm just projecting out. Oh, sorry, go ahead.
Yeah, I mean, so one of the reasons it's just not doable is just the poor user experience of the platform. If you want to, write a decentralized Uber that runs cost-efficient way in a scalable way right now, like you're gonna have a lot of work ahead of you, right? And people who are trying to build these businesses should not be trying to solve platform issues. It should be already known, well-solved problem for them, and they build on top of it. But unfortunately, we're just not there yet as a space. And as a space, we still have a lot more work to do, and that's the core things we're working on with Yella and Plutus.
Yeah, I know what you mean. It's still a construction site. It's still a work in progress for the whole blockchain industry. And what I compare it to is like the space race of the 1960s and 1970s, where to put a person on the moon, you didn't just send a rocket to the moon, right? First there was in-atmosphere testing, then outer atmosphere, then sending animals into space, then sending humans into space, then orbiting the Earth. And it was a progressive. There were mistakes made. There major catastrophes occurred. But in the end, eventually, they got someone to the moon and back alive, and it worked. And there was, a lot of the techniques that went into putting someone on the moon is kind of like the techniques they're using, the research in building blockchain technologies. So I'm just kind of drawing a parallel there between the two because it's such a huge effort. So I'm thinking, what is the end goal? What is the long range vision of blockchain? So that's why I used can you eventually build an eBay or an Amazon, because those are like some of the two biggest commercial applications that I can think of in the world, right? And so a long-term vision would be something like that. But I know the key is, what problem does it solve? Well, we already have an eBay, so you're not really solving a problem. The problem you're solving is the long wait for the third party to hold your money and verify everything is in place before they hand it over, and replacing that third party with automated blockchain technology is kind of what I'm thinking. But yeah,
that's a potential use case. I mean, I think that there's going to be different use cases that emerge through blockchain. I think that there's a little bit too much friction within blockchain to successfully run an Amazon or eBay at the moment. But who knows what kind of solutions are going to be taking place. And I think that smart contracts are going to open up multi-layered solutions to more complex transactions than the individual I sell to you, you buy from me. Maybe it might be a multi-party kind of thing, and it may progress from there. I think the playground is being set, and the innovations are going to come as the developers get more and more privy with the system.
Yeah, I mean, you're talking about, medium-term vision and long-term vision. And I think it's important to remember not to get ahead of ourselves, right? The Plutus Playground and Yella, they're all amazing technologies. If you were at PlutusFest and you were in the academic track, people were surprised. I mean, even with Yella, there's some academics that just really refuse to believe this is even possible. It's just too magical for them. When you walk them through the math and you show them it's possible and you show them it works in practice, and they're like, oh my god, it's just, I've been running this space for 10 years, I just cannot fathom that we managed to get this done. And so we have these amazing, mind-blowing experiences already, but we still have a long way to go, right? So for example, for Plutus, because I think this is more on topic, we have Plutus Core. And we have semantics of Plutus Core, and we have a certain limited amount of provability of Plutus. So we have to two stages to it. We have the AGDA proofs, which are like meta proofs about making sure Plutus smart contracts are always progressing and this kind of properties of computer science. And we have the K-framework proofs of Plutus Core to enable us to prove certain properties. But that's just only a single part of the pipeline, right? Because as you saw in our demo of the Plutus Playground earlier, you've got your Haskell code, and then it turns into JavaScript code, and then you got your Plutus Core code. And if we have these really nice proofs of the Plutus Core code, obviously this is really important, but this is only one part of the problem, right? We also have to verify that this Haskell code is working right, and we have to verify this JavaScript code is working right. And these are problems we've already started tackling, and we've actually already invested a lot of time and already have certain results on. But these things take time to prove not just a single component, but the whole ecosystem is secure. And so, I think one question people had at PlutusFest that were like community members is they're looking at this like, wow, like, you can write smart contracts on this and everything. Why are we only at 20%? It's because there's still a lot that needs to be done to enable all of these magical experiences that people like Charles really dream about. And so obviously we will not wait till we have the perfect product to ship something, and that's part of PlutusFest, right? It's like we know we don't have the magical experience that we would like to have in 5 years, but we've got something we want to show to you. So obviously we would try and be pragmatic about it, but we also try and in the roadmap not just lay out the 1 year vision, we try and lay out the whole vision, right? And so we still have a lot of work to be done until we get to the whole vision.
That was great. I think we're going to wrap this up. I think we are running a little bit over an hour, and I know the critics, I'll let both of you have the final word, but I know the critics will be like, oh, I wish it was 10 minutes long. But this is a podcast. I'd like to remind everyone that this is a podcast, so it's going to go for an hour. Today it's probably going to be an hour and a half, so it's a little special. We had a lot of fun at PlutusFest. We could probably go for longer, but we're going to try to stick to our format. I want to thank Sebastian and Rick, and I want to thank all the speakers at PlutusFest: Rebecca Valentine, Duncan Coots, Michael Peyton Jones, Jen Muller, Manuel Chakravarti, Alexander Nemish. He's listed on there. I don't think I heard him speak though. Pablo Lamella, Professor Simon Thompson, Charles Hoskinson, of course, Professor Agalos Kiayas, and Professor Philip Weidler. It was great experience. I think it was wonderful meeting everyone in person, and meeting Charles. It was incredible. It was incredible. I enjoyed that. I enjoyed that thoroughly. I think one of my aha moments for today, like something that I took out, was when Sebastian was saying that MakerDAO, they did their they verified their Ethereum contract with the K framework to make sure that it was formally verified and their smart contract was secure. And people are always asking, Cardano made a KEVM, the K framework on top of the Ethereum virtual machine. And I think this is a brilliant marketing ploy, because basically Ethereum developers are going to start verifying their stuff with using the K framework, and they're going to say, oh, what else does Cardano do? And then they're going to be exposed to Yella and everything that Cardano has to offer. So I think that this is brilliant. So thanks to everyone. Thanks to all the speakers. Thanks to Maki for this beautiful write-up. Go check it out on the forum. Send her a thank you if you have the chance. Thanks again to Christian and Kyle, because I know they're going to be helping us out this week. I appreciate that. Before I ramble on too longer, this is the episode 9 of the Cardano Effect. Thanks, everyone. Rick, Sebastian, do you have any last words?
Nope. Thanks, Philippe. I appreciate your time.
Yeah, I think as my last words is get involved. I think we're at a space in Cardano, or at a time in Cardano where we have Yella, it's working, we have Plutus, it's working, we have all these ways for people to get involved in the development process. And so if you're a developer you're listening to this podcast and you're like, oh my god, this sounds amazing, I want to get involved, it's now possible, right? Anybody can do it. This is an open source project, a decentralized ecosystem, and anybody can come get involved and have a lot of fun with us.
All right. Bye, everyone.